All right, so let's take a look at how we solve exponential and logarithms. Logarithms, you probably don't know unless you have taken chemistry. Chemistry, you will use logs. You won't get as in depth in logarithms as you will in this class. So today we're going to actually look at both things today, but let's start with exponential equations. So if you look at this example 1, well, here's just a reminder of, 3 to the 4th is 81, 4 to the 4th is 256, 4 to the 3rd 64. So we have some general, we've got 2 to the 6th, you might add him in there, 2 to the 6th is 64. Because we're going to have to be able to go between, if I see 27, I need to be able to think 3 to the 3rd. Or if I see 64, I know it could be 4 to the 3rd or 2 to the 6th. So basically what we have here is if I know 2 to the x is equal to 2 to the 3rd, then x has to be 3. If the bases are the same, then the exponents have to be equal. So so you're really trying to work to get the bases the same. So work to get bases the same. Do you notice that there is only one base? We have a base of 2, we have a base of 2. We don't have 2 2's equals 2 to some base. So it looks like that. So let's look at example 2. Example 2, do you have the same base? Yes. So if I have the same base, then the exponents have to be equal. And so I set my exponents equal, I solve, and I get 11 halves. That's it. Questions on example 2? Okay, now when it gets a little bit more interesting over here, we have 4 to the 3x, and you have 2 to the 8. Do you have the same base? No. So we need to rewrite that 4 as 2 to some power. Now I need to write it as 2 to some power because that's what I have over here. So you have to get it to the common thing. So 4 is 2 to what power? 2 to the 2nd. So I'm going to rewrite that 4 as 2 squared. I'm allowed to do that, right? Well, that 2 squared, the 4 is being raised to the 3x, so 2 squared is being raised to the 3x. Do you have the same base now? Yeah, 2 and 2. So we know, now, how did they get 6x? And it's powers, so remember with powers you're going to multiply. So 2 times 3x is 6x. So if I have 2 to the 6x and 2 to the 8, 6x has to equal 8. And then I solve. Questions on him? Alright, next one. Look at example 4. Now, can you take 27, is 27 equal to 9 to some power? Not pretty. What about 9? Can we take 9 to 27? Not really. But we can pull 9 down. 9 is the same thing as 3 squared. Right? 27 is the same thing as 3 cubed. So I rewrite the 27 as 3 cubed, raised to the 2x. So 3 times 2x has to equal 2 times 3x plus 2. Don't forget to pass it out. Okay? Questions on that one? And then you set them equal. Now, when I set it equal, I got 6x equals 6x plus 4. I subtract my 6x, and I get 0 equals 4. Well, is anything going to make 0 equal 4? No, so it's no solution. Now, if you solved it and you got 0 equals 0, then what would we say? We would say infinitely many solutions. There are lots of different things that we could put in there. Okay? So if you look at example 5 has the same thing going on. 4 and 2, I pull 4 down into 2 squared. And then I know my exponents have to be equal. Questions on those? Alright, let's go to what you tried yesterday. Okay, we did the odds. So let's look at number 1 and try that one together. We have a base of 3 and we have 27. What do you want to do? 3 cubed equals 27. So I have 3 to the negative 3r minus 3 equals 3 to the third. Then what? So I'd have negative 3n minus 3 equals 3. And then I'd solve from there. You okay for that? Okay. Number 3 looks a little different. This isn't like any of the examples we did before. So, how would you handle x squared times x to the third? Would give you x to the 2 plus 3 or x to the fifth, right? Well, did you change the base when you did that? No, the base stayed exactly the same. I just messed with exponents. So 3 to the negative 3n times 3 to the negative 3n would give me what? 3 to the negative 6n. Do you notice that everybody is tempted to mess with the 3? Like you want to make it 6 or you want to make it 9, but you didn't do anything to the x's. So you don't do anything to the 3's. So where did negative 6n come from? Added. Negative 3n and negative 3n gave me negative 6n. So that's equal to 3 to the negative n. Now what? Okay, so I really should be working on something other than this because this is super tiny. But I've got negative 6n equals negative n. Now what? How do I solve that? Okay, so what do you want to do? Okay, so add 1n to there and add 1n here. So that gives me 0 equals negative 5n. So what's n? 0. Okay, so along with that, what would 3 to the 0 be? 1. What would 10 to the 0 be? 1. What would a to the 0 be? 1. What would star to the 0 be? 1. Doesn't matter what you're raising to the 0 or 0 power, it's always equal to 1. So that's a little remember when. Okay? 4 is the other one that I want to take a look at because we have a fraction and this kind of combines what we remembered from Algebra 1 last unit. So how do I handle the 5s? Start there. So it'd be 5 to the what? 6x. Now 1/25, 125 is what? 5 to the third. So I really have 1 over 5 to the third. But if I take that, it's still not the same base. This base is 5. This base would be 1/5. So if I force it to the top, what does it become? 5 to the negative third. Now I have the same base, and I can say 6x equals negative 3, and I can finish it. Okay? Questions there? Okay. Number 8, if you look at number 8, you have a couple choices with number 8. Notice you have 16 and you have 64. Well, if you look at the chart in the bubble on the front page, you could either take it to 2's or you could take it to 4's. That's your call. You could either work in either one of those. So what you're going to do right now, and you're going to take 20 minutes, maybe a half hour. We'll see where we are in 20 minutes. I want you to go ahead and do 1 through 16. So fix the ones. Remember, you have your answers are over here on page 15. So you can check yourself. I should see some sort of solving for each one. Not just an answer because I told you where the answer